A teenage son of a knife grinder invents a method so powerful for designing fortresses that the French government classifies it as a military secret. For 15 years, he teaches it only to those with security clearance. Then, the revolution comes. And suddenly, this secret becomes the foundation of a new kind of education that will transform the world. Last time, we met Pierre-Simon Laplace, the Newton of France, who completed celestial mechanics and founded probability theory. We saw his demon of perfect determinism and his cool response to Napoleon. I had no need of that hypothesis. Welcome back to Men of Mathematics. Today, we enter the revolutionary era with Gaspard Monge, the man who invented descriptive geometry, founded the Ecole Polytechnique, and shaped technical education for centuries to come. Gaspard Monge was born on May 9, 1746, in Beaune, Burgundy. His father was a knife grinder and peddler, about as far from the aristocracy as one could be in pre-revolutionary France. Young Monge showed exceptional ability early. A map of his hometown that he drew at 14 so impressed local officials that they arranged for him to attend a military school in Mézières. At the school, Monge was assigned to help draft fortification plans, work considered beneath the aristocratic officer students. Asked to design a fortress defense system, a task that normally required weeks of calculation, Monge developed a graphical method that solved it in hours. The officers refused to believe his solution until they checked every calculation. Then they classified his method as a military secret. For 15 years, Monge taught his descriptive geometry only to those with security clearance. It was too valuable for fortress design to risk falling into enemy hands. What was this secret method? Monge invented a systematic way to represent three-dimensional objects using two-dimensional drawings, using multiple views, plan, and elevation that capture all spatial information. Before Monge, architects and engineers communicated through perspective drawings that couldn't be measured. After Monge, they had a precise language for three-dimensional design. Every CAD system, every engineering drawing, every architectural blueprint descends from Monge's descriptive geometry. Monge's method grew from stereotomy, the ancient art of stone cutting. How do you cut stones to fit together in arches and vaults? Each stone must be shaped precisely to bear loads and meet its neighbors. The Romans knew how to do this through trial and error. Monge made it mathematical. In 1781, Monge posed a problem that seemed simple. Given piles of dirt and holes to fill, what's the cheapest way to move the dirt? This optimal transport problem has become fundamental to modern mathematics and machine learning. It appears in economics for matching supply and demand, in image processing for comparing shapes, in machine learning with Wasserstein distances, and in meteorology for tracking air masses. Monge also contributed to the study of curved surfaces. He investigated the lines of curvature on surfaces, special curves that point in the directions of maximum and minimum bending. This work influenced Gauss's later development of differential geometry. The French Revolution swept away the old order, including the old educational system. In 1794, the revolutionary government needed to train engineers fast. Monge was called upon to help create a new kind of school. The Ecole Polytechnique was revolutionary in its approach. Science taught through rigorous mathematics. No distinction by birth. Talent was all that mattered. Practical applications alongside pure theory. The blackboard method of teaching. The Ecole produced an extraordinary concentration of mathematical talent. Cauchy for rigorous analysis, Fourier for the heat equation and Fourier series, Poisson for probability and physics, Carnot for thermodynamics, Fresnel for wave optics, and Coriolis for rotating systems. French mathematics dominated the early 19th century, largely because of Monge's institution. Monge accompanied Napoleon to Egypt as part of the scientific expedition. He helped found the Institut d'Egypte and contributed to the Description de l'Egypte, the massive survey that sparked European fascination with ancient Egypt. Napoleon trusted Monge like few others. Gaspard Monge rose from poverty to transform technical education. His descriptive geometry gave engineers a precise language for three-dimensional design. His optimal transport problem continues to generate research today. His Ecole Polytechnique became the model for technical schools worldwide, and he did it all while remaining devoted to Napoleon, a loyalty that would cost him everything. After Waterloo, the restored monarchy stripped Monge of his honors and expelled him from the Institut de France. His health broke. When he died in 1818, the government forbade students from attending his funeral. They came anyway. As E.T. Bell wrote, Monge was one of those rare spirits who excel both as creators and as teachers. His influence on French mathematics was profound. Next time on Men of Mathematics, we meet Joseph Fourier, the orphan who conquered heat. From revolutionary politics to Egyptian deserts to the mathematics of heat conduction, Fourier discovered that any periodic function can be broken into simple waves. His series changed mathematics, physics, and engineering forever. Thank you for joining us on this journey through mathematical history. If you appreciate the mind that gave us modern technical drawing, subscribe and hit the notification bell. New episodes release every week. I'll see you next time.